Hello, fellow hams. My name is Sandy, Kilo Bravo 3, Echo Oscar Foxtrot, and this little talk is about antenna modeling software. There are two free and popular apps available on the internet, MMANA and EZNEC. I'm going to contrast and show my preferences between these two pieces of software, and I plan to use these tools to create the perfect antenna for three different radio situations. The first one is a 40-meter dipole for a monoband QRP CW rig. In my case, it's the QCX Mini, which is a 40-meter band rig, the one that I own. It doesn't have a tuner, and we want a resonant antenna, so we don't need a balun of any kind. All right, let's go ahead and open up MMANA. We'll start with that. And you can see that when it first opens up, we get the View tab, and this shows the good old-fashioned Cartesian coordinate system, X, Y, and Z. The only thing you need to remember about this is that the Z is in the up position, okay? And if you go to geometry, all right, you'll see that it consists of a place where you can put in 2 points, XYZ1 and XYZ2. And MMANA takes those 2 points and draws a line between them and then uses that to say, okay, this is an antenna. We'll call this a wire antenna between these 2 points. All right. It also will put in a radius of the wire and segmentation, but these are done automatically. You can vary them. But let's go ahead and start off with the perfect dipole for 40 meters. We're going to open up an MAO file. I'll call this the perfect dipole. All right. Now this is just a guess on my part. It's a 40-meter dipole. I know dipoles are half-wave antennas, so half of 40 is 20. So let's go from plus 10 to minus 10. Minus 10. Plus 10 to minus 10. That's a 20-meter wire. And we're going to put it up at a Z height of 10 meters at both ends. All right, so it's 10 and 10 for both ends of the antenna. And if we look at this in our view, we can see, here we go, there's our antenna. It's up 10 meters. It's 20 meters long. And that red circle in the middle, what that is let's go to geometry. That is our source. That's where we attach the radio. They call it W1C because wire 1 is, we only got one wire, wire 1, and C means center, so it puts that in the center. All right, so now we're ready to calculate. Go to the Calculate tab. We see that we're set to frequency 7.05. We got a height. We haven't given it any additional height. It's up 10 meters. We've said copper wire. We could have made it aluminum wire. We could have made it iron, pipe, copper pipe. But let's just keep it at copper wire. All right? So we're ready to see if our guess was anywhere close. All right. This gives us, the calculate will give us our SWR, gives us our gain, front to back ratio, and we got an SWR of 1.81. Well, let's see what that did. Okay, we've got current. Yeah, got current. Typical dipole pattern. Current max in the middle and goes to 0 at the ends. All right, well, but I promised you perfection, right? So what MMANA does is has an optimize button that allows you to try for perfection. It gives you all these parameters you can try to optimize for. And you can optimize for gain, which we don't care about. Front to back, nope, not in the dipole. Elevation, no, you get what you get in dipole as far as the angle of your signal going out. And no, we don't even care about the imaginary impedance. We just want SWR to be perfect. Now, what do we actually optimizing? Well, we've only got one wire, so we're going to optimize the heck out of that one wire. All right, X1 is the left side. We're going to let that step in 1 centimeter increments and vary between 0 and 20 meters long. It starts at a length of 10 meters. All right, X2 is the other end of the wire. We're still in wire 1, just one wire. We're going to let this associate with point 1 in a negative way. So if point 1 goes to the left-hand wire part of the wire goes to the left, the right-hand part of the wire will go to the right, and vice versa. And the right-hand part of the wire is starting at minus 10, just like the left hand is starting at plus 10. All right, for the height, okay, that's the Z coordinate, and the height is starting at 10. We're going to let that vary from 0 to 20. We don't want it to go higher than 20 meters. That's, 60 feet. Don't have a 60-foot pole or a 60-foot tree. So we're going to let that vary between 0 and 20. And one end of the wire is going to go up with the other end of the wire. So position 3 is going to go up exactly as position 4. So 4 is associated with 3. They're going to go up and down together. So this antenna will vary in the lengthwise and the height simultaneously. All right, let's see if it'll do it. Start. Something's happening. Wow, that was quick. Wow, didn't give us time to even think. That was probably less than 2 seconds. It says it's an SWR of 1.0. That's perfect. Let's see if that's perfect. All right, let's view our antenna. Yep, we got current. Where did we end up? Geometry is 10.13 on a side, so it made it a little bit longer, and 6.9, so it brought it down closer to the ground. 6.9 meters up, 10.13 meters on a side. All right, well, what kind of an antenna do we have? Okay, this is a typical dipole pattern. It likes to radiate off the sides and mostly in the up and down direction. Okay, if you try to radiate off to the side for a DX thing, well, you've already lost 13.3 decibels from G max if you go off to the side. So this likes to radiate up and down, which is good for an NVIS antenna. That's NVIS, Near Vertical Incident Sky Wave. So this will get you out to about 400 miles during the day when NVIS is workable on 40 meters. So you can get maybe New England, you can get the Carolinas, but I wouldn't try to get California. No, won't get California. It also works fairly close in. I've managed to get an NVIS pretty decent contact with a friend in Mount Airy. We did an Aries WinLink session and did peer-to-peer on 40 meters, and this kind of a pattern antenna worked just fine. All right, so how about the 3D plot? Let's take a look at that. Again, we just have a typical dipole pattern. It likes to go straight up. The purple is the maximum radiation pattern, and this is the direction of the antenna, so yeah, it kind of goes off to the sides a little bit. All right, so now we have the perfect NVIS antenna for 40 meters. Okay, this is perfection. You can attach coax to that. It's at 50 ohms. You can attach that directly to your radio. And yeah, you don't need a tuner. You don't need a balun. You're good. All right, perfection. All right. Well, let's contrast MMANA with EZNEC in the same situation. We want the perfect 40-meter dipole. So let's bring that down and bring up EZNEC. All right, we can view the wires as before. Hit the wire tab. You can see the numbers are the same, 10.13, 6.9 height. They like diameters rather than radius on the wire size here. And it's copper wire, so it's the same situation. Let's view our antenna. There we go, same height. Same XYZ coordinate. We can also calculate our SWR. Let's run that. EZNEC likes to give you the whole shebang, so they plot the whole plot there. Let's put this down to 7.05 megahertz, and you can see that we got 1.0 SWR. So EZNEC and MMANA agree that this is the perfect dipole, but where MMANA made finding this trivial almost, EZNEC does not have an optimize button. Okay, they can do a lot of things, but they can't optimize. So in order to find this perfect dipole with EZNEC, you'd have to manually search for these numbers by trial and error. Now, that might take you all day, but you could eventually find it that way. But MMANA makes it so much simpler just to hit that optimize button and then tell it how to optimize to find the perfect antenna. And we'll be using that extensively. So yeah, if you know what the dimensions are, EZNEC is great. But if you're trying to find or design the perfect antenna, my preference is MMANA. All right, now on to antenna situation number 2.